been throwing out a lot of names, and maybe you wonder if there's some rules. There are. You could memorize them all, or memorize a couple easy rules. Not too bad. So for the acids, if we're going to name acids, first of all, you're looking for something that starts with an H almost always. These are the common acids. There's two types. You can have an acid with a polyatomic or without a polyatomic ion. So let's name the ones that don't have polyatomic ions first. It's always going to be the same pattern. Hydro plus the root of the anion, so that's the negative part because you have this H plus and a negative part for your acid. So hydro something ic acid. That's always the pattern. So for example, HCl is hydrochloric acid. If I had HF, it would be hydrofluoric acid. That's the pattern. Then we have acids that contain a polyatomic ion. So for this one, it's going to be, there's no hydro, you just start with root of the polyatomic ion. So for example, nitrate, you're going to start with that nitr. Sulfate, you're going to start with the sulf. So just the root of the word of the name of the polyatomic ion, and then you either say ic or ite, and then you say acid. So to figure out if you say ic or ite, you're going to say, well, the ates, so polyatomic ions that end in ate, like nitrate, sulfate, phosphate, they're going to have acids that end in ic. And polyatomic ions that end in ite, like nitrite, sulfite, phosphite, their name is going to end in us. So sometimes kids have a hard time remembering which ones are the ics and which ones are the us's. So I can't believe I ate that, ic. So ates are going to go to ic. And then to remember what the ites do, it's kind of like speaking with a little bit of slang. Somebody said, you know, is that cool? Is that fine? You say, yeah, it's ite with us. It's ite. So it's ite with us. And so, you know, ates go to ic, ites go to us. And let's look at some. So there's no polyatomic ion here. So I know I'm going to start with hydro. So hydro, this is sulfur. So it's going to be sulfur. Hydrosulfuric acid, following my pattern. Then here, since I've memorized my polyatomic ions, I know that this is sulfate. Can't believe I ate that, ic. So this is going to not have the hydro to begin with. It just starts with the root of this polyatomic ion, and I just have sulfuric acid. This is sulfite, SO3, with the 2- charge is sulfite. So instead of being sulfuric, this one's going to be us, because it's ite with us. Sulfurous acid. Next, I've got H3P. I know that since there's no polyatomic ion, I'm going to start with hydro. So this one is hydro, phosphor, ic acid, hydrophosphoric acid. And the next guy, I know this one is phosphite, so ite with us. I won't start with hydro, I'll just start with that phos. So I've got where that phosphor. So I have phos for us, O-U-S, ite with us, acid, phosphorus acid. And then for that last one, I have phosphate, PO4 with a 3- is phosphate. So 8 goes to ic, there's no hydro. So I'm going to have phosphoric acid. Done. So what about bases? Bases are pretty much just going to be ionic compounds. This is a really common exception. You're going to see this a lot. That's ammonia, so memorize ammonia. But all the others, you're just naming ionics. And if you remember from naming ionics, you say the name of the metal, name of the nonmetal, but change the N to IDE. Some metals have more than one charge. Most of those transitions, except for silver's always 1, zinc's always 2. But all your other transition metals are going to use a Roman numeral to tell what charge you have. So, here we go. Here's my ionic compound. By the way, I know it's a base because bases contain hydroxide, oxide, or amide. So I've got this ionic compound. I just say the name of the metal. The metal is barium. And it's bonded with hydroxide. barium doesn't have multiple charges, it's not a transition metal, so I just have to say the name of each of those guys. And since this is a polyatomic ion, I don't change the end of its name. Already as I do. Then here we have sodium and oxygen. Sodium's not a transition metal either, so I don't need to say what charge it is, no Roman numerals. Just say sodium. And then the oxygen, I changed the end to IDE, so oxide. For this one, I have potassium. K is potassium. Again, I have chosen a metal that doesn't have that isn't a transition metal. Okay, so I don't need to say the charge. So potassium, and then the second part is hydroxide. That's the name of that polyatomic ion. And then here we have lithium. Once again, not a transition, so I won't use a Roman numeral. Just lithium, and NH2 is the polyatomic ion amide. So lithium amide. And I guess that's it for naming. So if you need to decide if something is strong or weak, or if it's an acid or base, here's a few things you need to do. You need to memorize your 8 strong acids. It's on the Stuff I Should Know sheet, the one we got off chemibear.com. Wonderful website. The 8 strong acids, the way I remember it is you're going down the halogens, except for you skip fluorine. So that's going to be hydrochloric acid, hydrobromic acid, and hydroiodic acid. Okay, so I got those guys. And then from this chlorine, I'm going to go ahead and go to chloric acid. That's a 1 minus, so HClO3. And also from there, I'm going to go to perchloric acid, HClO4. And building off of this iodine, I'm going to go to periodic, HiO4. And that's 6 of my 8. I don't really have anything for you except for these guys show up all the time. H2SO4 is sulfuric acid, and nitric acid, HNO3. So those are the 8. Memorize those strong acids, and then any other acid, anything else that starts with an H, is not going to be strong. It's going to be weak. There's one weak acid that shows up a lot, though, that you'll want to memorize as well. CH3COOH. This is acetate. The H is at the end. So that's acetic acid. Or you could also call that ethanoic acid. Eth because there's 2 carbons. Okay, for bases, bases are going to contain, we said in that last slide, hydroxide, oxide, or amide. If it's a strong base, it's going to be soluble and contain those 3. And it has to be soluble because if it's going to produce hydroxide in water, well, it has to let go of its hydroxide. And if it lets go of the oxide takes on an H plus immediately and leaves the water behind to be hydroxide. And same with the amide. The amide has a strong attraction for an H plus, so it'll take an H plus off of water and leave a hydroxide behind. So strong bases are soluble and they contain one of these 3.